for class today, I need all your computers closed. Yep, close. I know you're probably playing a wonderful game, but close it down. Or watching something wonderful on YouTube. You need a... No, you don't need a calculator. Yeah, the whole point is you don't need a calculator. Okay? We are going to answer number 4, the review question number 4 here. We're going to work it as a class without a calculator. Face of horror, I got 1. Anybody? No, everybody else was cool. It was just you. You were the only one that overreacted. Okay. I intentionally did this last period, unintentionally. Like 4th period, they made me angry because nobody had their calculators. So I'm like, fine. If you don't want to come to class prepared, we'll do it without calculators. And it ended up, I think, being really beneficial to just work one time, to work the whole problem without a calculator. All right? Yes. You're shaking your head? No. Yes. Here we go. I'm going to read it. I want you to remember these. The formula's right here. Okay, the formula's right here. F lowercase g, write this down. F lowercase, so you have it right there on your paper. Force G, force of gravity, gravitational force, however you want to say it, is equal, in our formula here, you have this stuff, you just plug it in and it gives you the answer. G, big G, is the gravitational constant, which is given to us. Big G is always 6.67 times 10 to the negative 11th. What?
Because I'm living right.
I got you.
How about we just partner up, you two, and you're just gonna watch.
All right.
Okay, and participate because we're all gonna work this together. Okay, and the unit for that is newtons times meters squared divided by kilograms squared. Okay? Do I know how the dude got that? No. I mean, there was the experiment with the string and the thing and the bar and the 2 masses. And I'm glad he was very smart and figured that out for us. We don't need to worry about that in this class. If you guys go on and be more advanced later, that you'll learn all that. Okay? We're given it, just like you're given pi. And at first you might not understand pi. But you know, hey, it's 3.14 something, something, something. Okay? All right, so force of gravity equals the constant times the mass of object 1 times the mass of object 2 divided by the distance squared between those 2 centers of mass. Does that make sense? Looking at me like I've got a horn, like I'm some kind of human unicorn hybrid thing. Is that a thing? No? Did I just make that up? It's a thing now. What? Yeah, I had an accident with markers. So you've got, let's say, Earth and the moon not proportionate. You're not measuring like the distance from the far side to the far side, right? You're measuring center of mass to center of mass. Does that make sense? You don't have to put that in your notes. I'm just clarifying that that's the distance that we're talking about, okay? Now, let's read the problem. And do you remember how to use a table or chart of known things? Do you remember that? We used to make it right over here. We're going to put one right over here. This way we can say known things. Put that on your paper somewhere. Known things. Here we go. I'm going to read it. You put things that we know in the chart of known things. The mass of the Earth is 5.98 times 10 to the 24th kilograms. Is that something that we know? Yes, let's put it in our chart of known things. So M1, we'll call that M1, is 5.98 times 10 to the 24th power. We're also given mass 2. Mass of the moon is 7.35 times 10 to the 22nd. Second known thing. Yes?
What did you say the first one was?
5.98 times 10 to the 24th power.
5.98.
Correct. Times 10 to the 24th power. Good. And then it says if the distance between the Earth and the Moon is 384,000 kilometers, that's another known thing, distance. 384,000 kilometers. And then it asks, what is the gravitational force on the Moon? Is that a known thing? We know that we don't know, right? So we're going to put it in here. Force, gravitational force, is a question mark. That's what we're looking for. Now, is there anything else that we will use in our formula that I haven't put in our known things? Gravitational constant. Constant. There we go. And that was 6.67 times 10 to the negative 11. Okay. We have everything we need to fill in our formula. So I'm going to pause. You're going to look at your formula, look at your table of known things, and rewrite the formula with the stuff you know in it. Make sense? Go ahead. Give you a head start. What do I do now? I don't have a calculator. I can't do the math. Yes, you can. So what do I do first? Multiplication. Guys, we've got, how many numbers do you see in this equation? What? 4. Thank you. Other folks today, like 1, 2, 3, 4, 5, like 19, 20, whatever they're counting to. There's 4, right? We've got 1, 2, 3, 4. And they're like, each of those numbers has a bunch of numbers. Like, it's just one number. Okay? It's a digit number, I guess. I don't know, but it's one number. Do you guys want to attempt it on you? You want to do it together? Okay. 6.67 times 5.98. Here we go. What's 8 times 7?
15.
Times.
56.
56. So put a 6 here. The 5 carries. 8 times 6 is 48 plus 5. 53. Carry the 5. 8 times 6 is. You didn't hit save, peer tutor lady. Huh?
What the heck?
What the heck? Well, thanks for showing up.
Of course.
Congratulations. All right, cool. Where were we? We did 8 times 6 was 48, plus the 5 was 53. All right, next one's 8 times 6 again. 48 plus 5, 53 again. All right, reset up here. You guys remember how to do this now? What do I need right here?
0.
A 0, placeholder, right? So we're going to have a placeholder for the 8. 9 times 7. Carry the 6. 9 times 6. 54 plus 6. 60. Carry the 6. 9 times 6. Plus 6. Okay, reset up here. 2 placeholders now, right? 5 times 7. 35. Carry the 3. And 9 times 6. Oh, excuse me. 5 times 6. 30 plus 3 is. 5 times 6 is. Plus 3. And now we do what? We stop that noise making. All right, so we're going to use noisemaker. 6 and 0 and 0 is. 3 and 3 and 0 is. 3 and 0 and 5 is. 5 and 0 and 3 is. 6 and 3 is. 3 is. Okay, now, how many places over do I put the decimal? 2, 3.
4,
Guys, count up all the numbers to the right of all the decimal points.
4.
1, 2, 3, 4. So I'm going to, starting here, I go 1, 2, 3, 4. I'm going to have 39 point, I'm going to round, okay, I'm going to round, I'm sorry, but I'm going to round 39.9. Is that fair? Is it okay? Give me permission to round, otherwise it's going to take a lot longer, okay? All right. $39.9 times what? 7.35. What is 5 times 9? 45. What is 5 times 9? Plus 4? 49, carry the 4. 5 times 3? Plus 4? Reset. Placeholder. 3 times 9? 3 times 9? Plus 2. 3 times 3? Plus 2. 2 placeholders. Reset the top. 7 times 9? 7 times 9? Plus 6. 7 times 3? Plus 6. Add them up. 5 and 2 zeros. 9 and 7 and 0. 9 and 1. And 9 and 3. 22. Good. You were like, who was that? You were like on it. 2 and 1 and 1.
13.
And 9. 13. 1 and 1 and 7. And 2. Boy, we're really getting whatever. How many decimal places?
2.
3. 1, 2, 3. 293.265. Could we put that in? Oh gosh, hold on. So the numbers you multiply, what do we do with the exponents then? The 10 to the whatever power. When multiplying numbers with times 10 to the whatever, you multiply the number part and you do what with the 10 to the whatever power? Add. Very good. Good memory. All right, so we're going to be times, what's negative 11 plus 24?
13.
Plus 22?
35.
35. Times 10 to the 35. Okay, yes. Yes. All right, so I'm going to rewrite that now. I'm going to put it right here. We're going to separate these two out. Where's my brown marker? Doesn't show up very well, but that kind of works. So we're going to rewrite the numerator. All of that we just turned into 293.265 times 10 to the 35. But wait, is that proper scientific notation? Shouldn't the decimal be between the 2 and the 9? Shouldn't it be between the 2 and 9? Shouldn't it be after that first non-zero? Okay, cool. So to move it 2 more that way, this would be a 7, right? Okay, so we're going to change this to a 7, and we're going to move this over here. There we go. We've got our numerator rewritten. Now we've got to do our denominator. This is going well, by the way. So far, so good. 384,000 kilometers squared. The formula, though, when they're talking about distance, doesn't it have to be in the right unit? It's got to be in the right unit. It's not supposed to be in kilometers. It's supposed to be in meters. The base unit. They want it in the base unit. Could you leave it in kilometers and then you just multiply by 1,000 later.
Yeah.
You could, I think it's probably best practice, maybe I'm wrong, but I think probably best practice to go ahead and convert to start. Okay, so how do I get 384,000 kilometers to be meters?
Add 3 zeros.
Add 3 zeros. Or multiply by 1,000, the same thing, right? Because kilo means
1,000.
1,000. So this means 384,000 meters. 1,000 is a what?
Million.
A million. Okay? So we're just going to get rid of this over here, put another 3 zeros and an M. Okay. But we're trying to do this without a calculator. So scientific notation really is our friend, isn't it? Scientific notation is really our friend when we don't have a calculator to use. Okay? So how do I put this in scientific notation? Where's the decimal going to go?
Between 3 and 8.
Right here. Good. So let's do that. It's going to be 3.84 times 10 to the
37. 8.
1, 2, 3,
8.
4, 5, 6, 7, 8. If you said 8, good job.
Let's go.
Times 10 to the 8th.
8.
Okay? But
8.
we need to do what to that? Square it. Oh my gosh. To square something means to do what? Multiply it by itself. So let's do that. 3.84 times 3.84. I'll go ahead and give you guys a head start working that one. In fact, try not to look up here. So 3.84 times 3.84. You work it on your end. I'm going to work it up here. I'm going to keep my back to you so you can't peek. Like this. Not kidding, but. All right. So here's what I did. You guys, if you're still working, that's fine. I did our whole process, got 14.7456. Did you guys get that too?
Yep.
Fantastic. Times 10 to the 16th because we had times 10 to the 8th times itself, and you add the exponents, we got 16. But wait, that is not in scientific notation, so I moved it one more to the left, which means it'd be times 10 to the 17th. My exponent work's getting better, isn't it? Yeah. Daughter number 1, aka peer tutor over there, is like, wow, Dad, you're doing great. It's okay, you can give me compliments, I like it. Okay. Am I wrong? I think I'm right. Last period I was wrong. This period I'm right. We good? So we're going to put that in right here, okay, for our denominator. Just hurry up and finish, for crying out loud. We're here just he's trying to be quiet and it's just taking what? Yes, take the pass. All right. So we put in 1.47456 times 10 to the 7. Oh my heavens, that's going to be a bear to divide, isn't it? What do you think we could do? Could we? What could we maybe do to those?
Round up.
Could we round them, please? Right.
Yeah.
So can we just make this 2.9?
Yeah. Of course.
And could we make this 1.5?
Yeah.
Sure. Sure. I like that.
Totally.
Oh, okay. That makes me feel a little better. Well, here we go. 2.9. Does that go in or out of the little boxy thing?
It goes out.
No, it goes in.
Dang.
2.9 divided by 1.5. How dare you?
Oh no, I was just.
I'm
like,
so disappointed in you.
That was Cameron's fault.
Oh, it was him. Okay, my bad. You were just doing what he told you.
Yeah, exactly.
Wait, isn't that worse?
No,
All right,
it's
here we
not
go.
bad.
Could we just like pretend these are over here? Could we do that?
Yeah.
All right, cool. So we're gonna put this right here, and we're gonna say, can 15 go into 29?
One time.
One time. 1 times 15 is?
15.
What's 29 minus 15?
14.
Can 15 go into 14?
Nope.
No.
No. Can it go into 140?
Yeah.
How many times?
15.
9 times. What's 15 times 9?
45. Or not 45.
140.
Close.
135.
All right, hold on. We're not sure.
120.
So we've got 15 times 9. What's 9 times 5?
45.
What's 9 times 1?
135.
Plus 4.
135.
It's 120.
135. And then we have 5, right?
Yeah.
Bring down another 0. 3. That'd be 45. Whatever. Could we say our answer for force
1.9
in, or force of gravity is 1.9
times 10 to the power of
times 10. Now we're dividing. What's the rule about dividing with exponents? What? What's the rule with multiplying with exponents? Add. So with division it would be subtract. Okay, so we had 37 minus 17.
20.
Hold on. Okay. Now we're going to check our work with calculators. Get your calculator out. Go ahead and get your calculator out. Get your calculator out, Talon.
I don't got one.
Go borrow one. Don't be helpless. Go borrow one. Make sure I get it back. Looks like I'm missing one already. Unless somebody just borrowed it. That's good. By the way, they're on the supply list for this class. You should have one. Well, don't steal mine. All right. Now, here's how you put it in the calculator. How many of you all are sure that you know how to put that in the calculator?
If I do.
Oh, I know how.
Easiest method. Here we go. Shh. Step by step. Here we go. Open parenthesis. 6.67 times 10, negative symbol, 11, whoa, times 10, caret.
Yeah.
Caret. Guys, here it is. That symbol right there. You guys remember this one?
Yeah.
So you got 6.67 times 10, caret symbol, negative 11, close parentheses, open parentheses, 5.98 times 10, caret, 24, close parentheses, open parentheses, 7.35 times 10, caret, 22, close parentheses. Yeah, I'm not done yet. Divide the forward slash, divide, do it. You're just laughing because there's a lot. There's a lot, but you can put it all in there. So divide, right, the forward slash, and then we're going to put in 384, 0, 0, 0, 0, 0, 0. That's 6 zeros, x2, because we're going to square it. Or you can put in caret 2. Enter. What do you get?
1.98.
1.9?
Oh, you're wrong.
1.9?
8.
Okay, we did a lot of rounding, right? 1.9 times, what does it say? Times 10 to the 26?
20.
Should be 20. Double check you can hit the back button to double check.
It's 20.
You must have put in one of these exponents wrong. Check it.
I put everything right.
It just says what? You probably put the wrong symbol in somewhere. Go back. You see the arrows?
It's 20.
It is 20. We got it right. Now the difference here is rounding error. Because you have 1.98, right?
Yeah,
Okay, so we did a lot of rounding, didn't we?
we did.
Yes. Okay, listen. Huh? You're just what?
Smart.
She's hurt.
Yeah, you didn't put all the zeros in. 3, 8, 4, 6 zeros, not 3. Try that. Yes.
Can I go to the bathroom?
Okay.
Is that a yes?
I said okay.
Just go.
All right.
Who
Guys,
cares?
how do you feel about yourselves? Do you need a calculator to do this math?
I don't.
No!
It takes way quicker, so yeah.
Guys, okay, all right, no, fair enough, fair enough. You say it's way quicker and there's less room for error if you use the calculator. Do we agree on that?
Yeah.
Do you think doing it once by hand gives you a better appreciation for how it works and how difficult it would have been for these mathematicians doing it without a calculator?
Oh, yeah.
They had to do this stuff by hand. Did they have slide rules in the 1600s? I don't know. They didn't have calculators. But what's this thing in here?
A brain.
It's a calculator.
Why does it work for everybody?
Right there. He made how many calculations? I threw it, and he tried to be cool about it. But he had to make a thought, like, I'm not going to overreact to this because I want to be cool about it. So he's like, so he still dodges his head a little bit,
Wow,
right?
that was just a slip.
It was a slip. No, it wasn't. You made calculations just like that.
That is
Yes.
true. I was
Go back.
calculating how much time I had.
You almost hit my coffee. You were so close to death you don't even know. Did you see that? The calculations? With my peripheral vision, I caught that marker. This mathematical calculations going on in your head, you don't even think about it. All right, cool. The remainder of the time. The remainder of the time, you guys can work on the questions 1 through 10. Some of you did it yesterday, and you should not have.
Oh, it wasn't me this time.
Yeah, I'm sure it was.
No, it wasn't. I learned my lesson.
I remember every one question.